So today we're talking about polynomials, zeros, and factors, and how all of those things are related, because we've really already talked about all three of those things, but we haven't looked at how all three of those are related to each other. So, for this equation, I want to know what would make this equation equal to 0. So, like, what number could I plug in that would give me 0 for this equation? So, you use Desmos if you want. Guess and check. What could I plug in that would give me 0 as my answer? Everybody get out your Desmos. Get out your Desmos here. Here's the option for you. Type the function in. So you're going to type your function in. So like, if I do f of 1, I get 90, right? So what that's doing, whenever I type that in, it's doing 5 times 1 squared times 1 minus 4 times 1 plus 2 times 3 times 1 minus 5. All right, it's plugging 1 in for it. But if you type the function in, you can do f of 1, it'll give you that answer back. So think through and see if you can find a number, there's more than one answer to this, that would give you 0 if you plug that number in. Zero, okay. So if you do f of 0, that gives you 0. So 0 is one of the options. If we think about doing this by hand, because while we definitely can use Desmos for this, one of the things we're thinking about is how to do this by hand here. Like if I do this, if I do f of 0, I would get 5 times 0 squared times 0 minus 4 times 0 plus 2 times 3 times 0 minus 5. Like if we're thinking about doing this by hand, which means I'd have 5 times 0 times, right here I'd get negative 4, here I'd get 2, here I'd get negative 5. And so I end up getting 0 because anytime I'm multiplying something by 0, what do I get? 0 times anything is 0, right? They're your easiest multiplication tables. Henry has started his multiplication tables in class, and he's only passed the zeros and the ones so far. But he got the zeros really easily, right? We're working on 2s right now. Because 0 times anything gives you 0. So this piece right here is the only part that's 0, but it doesn't matter because it all gets multiplied together and it ends up being 0. So x equals 0 is one of the values that makes this function equal to 0. All right. Others. There's more. There's 3 more specifically. Got another one? 4. Okay, let's think about it by hand. This may help us find the others, because I've got 5 times 4 squared times 4 minus 4 times 4 plus 2 times 3 times 4 minus 5. So what I end up with here, I've got 5 times 4 squared is 16, but right here 4 minus 4 is 0. There's the key, right? That's what's going to make everything else 0. This is 6. This is 12 minus 5, which is 7. So I will end up with 0 when I plug in 4. And the reason is because of this little piece right here. When I plugged in 4, I ended up with a 4 minus 4, which gave me 0. It's not going to be 5. Negative 2 works for that same reason. Because if I plug in negative 2 right here, negative 2 plus 2 gives me 0. And so 5 is like a good guess, but look what happens here for this one. If you do 3 times 5 minus 5, you'll get 15 minus 5, which is 10. Right? So that 3 is messing us up right there. We can't just use the opposite sign with that. Anybody know what number we could use for that piece? Because that's what we need to be thinking about. It's not a whole number. So that part's harder to come up with. But really, once I show you what to do, it's very easy to come up with. If it's just a simple one like this, x minus 4x plus 2, you end up using the opposite sign. If you just have an x by itself out here, it's just 0, because that would make that part 0, right? But if you have something like this, you need a value that would make that 3x minus 5 equal to 0, because if that is 0, the whole thing will be 0. So what you can do is you can just say 3x minus 5 equals 0, and then just solve that little equation right there. So you could add 5 to both sides. 3x would equal 5. Then what would we do? Divide by 3. So x would equal 5/3. Most of the time we'll just leave it as a fraction, but it's 1.6 repeating if you divide there. So those are your 4 zeros that you would have for this function. So we're going to walk through a few more of these. So these can actually be really fast to find just from the equation, more so than looking at the graph. However, if we do look at the graph, so we were typing these into Desmos, if you do look at the graph here, make that full screen for us, if I click on my zeros, right there's negative 2, right there is 0, right there is 1.6 repeating, which is 5/3, and right there is 4. So those are all the zeros of my graph. So one way I could have done this is to look at the zeros of the function. They match the factors. They're just opposite signs, right? Also notice something right here. What type of 0 do we have right here at 0? What's different about that one than the other 3 when we're looking at the graph? It's a bounce, right? It just barely touches and goes back up. So this one is a double root, right? It counts twice as a multiplicity of 2. What do you notice over here about the equation? There. We got a square right there on the x, right? So when you have a square on one of your factors, it causes that root to be a double root. Or if it's third power, it'd be triple root. If it's fourth power, it'd be fourth root. So the key takeaway here for this is that if x minus, I'm going to just use an a right here, but it could be any number, x minus 3, x minus 7, x minus 12, whatever, is a factor, then a is going to be a 0 of that function. Okay, so these can be really fast to find from just the equation without having to graph them. Plus, we're going to have to look at some imaginaries towards the end of these notes, so some of it's going to be pretty important. So if I have, what are the zeros of f of x equals 3x minus 2 times x plus 7 times x minus 4? All right, that means anything I could plug in that would give me zeros. It also means the x-intercepts of the function. So I could graph it for sure and see it, but what we're trying to do right now is connect what these factors look like to the equation, to the graph, to all of that. So we want to be doing it by hand. So give me a number that I could plug in that would give me 0 for this function. 0 actually will not work on this one. It will not, because I don't have like a x out here that's just being multiplied. So like if I plug in 0, like for this factor, I would get negative 2. Right here I'd get 7, and here I'd get negative 4, so I wouldn't actually have a 0 for that. What do you think, Mabry? 4 works. That comes from this part right here because if you wanted to, you could do this, x minus 4 equals 0. We're seeing what makes this 0, right? And then we could add 4 to both sides, so x would equal 4. But you don't have to show work. You can just know it's the opposite sign right there. All right. What else would work? -7. So that comes from right here because x plus 7, if we set it equal to 0, we just move the 7 over, we get -7. All right. The third one's a little harder to find. What would we do, Mabry? 2 over 3. Very good. Because we can just say 3x minus 2 equals 0. Add that 2 to both sides. 3x equals 2. Divide by our 3. And so x equals 2/3. So I've got 1, 2, 3 of those here. Yep. You also can do 0.6 repeating as well. Yeah. And if we graph it, because you can definitely graph these here. So, like, I'm trying to give us several options on how to do it. If we graph it here, f of x equals 3x minus 2 times x plus 7 times x minus 4. I think I'll have to zoom out a little bit, but if you look right here, -7.6 repeating, which is our 2/3, and 4 are our 3 answers for this. Those are our zeros. So, if I'm looking at example 2, I'm taking each factor, and I'm thinking about what would make it 0. Now, this one, will 0 be an answer for this one? It will work because of this 3x right here. So if you have like a GCF that was pulled out where it doesn't have plus or minus, so that will be 0. What would we have for the x minus 2? Positive 2. What about the x plus 3? -3. And a little note about this, because it has a square, this is going to be a multiplicity of 2. How about this last one? That one's one we got to think about a little bit harder, right? But all we've got to do is say 2x minus 3 would equal 0. So we would add that 3. So 2x equals 3. We'll divide by 2. So x would equal 3 halves. So, and you can do 1.5 also if you want, if you'd rather have a decimal for that. So this one has what we would call 4 distinct zeros. It actually, we could say it has 5 real zeros because -3 counts twice there. Like if you multiplied this out, it'd be to the 5th power for it. Okay, questions? Okay, so there are going to be some zeros that we find sometimes that aren't whole numbers, and we are going to need to know how to find those using the quadratic formula. So this question is just a quick review of the quadratic formula. So do you guys remember doing it? Would have been math 2, -b plus or minus square root b squared minus 4ac all over 2a, right? Probably there was a song. I don't know which song. Very good. So there's so many varieties of songs. Yeah, yeah. Speaking of, I think Hunter got some extra credit on some test because he sang the song there. So this is quadratic formula. It can be used when we have something that does not factor. So like right here, x squared minus 5x minus 8 won't factor, because if I try to factor it, I got to multiply to get negative 8, but I got to add to get negative 5, and the only things you can multiply to get negative 8 are negative 1 and negative 8. I'm sorry, negative 1, positive 8, positive 1, negative 8, negative 2, positive 4, positive 2, negative 4, and none of those add together to give you negative 5. So there are lots of quadratics that don't factor. So when that happens, you have to use quadratic formula to solve that last little bit. So the A's, B's, and C's, they are the numbers in front of your variables. And the number in front of your x squared is always your A. The number in front of your x is always your B. The last number of the constant is your C. You need to have everything on one side. That's all happening here. What is my A in this case? Because I don't see it. I don't have a number in front of the x squared. So what is there? It'd just be 1 right there. So in this case, my A is 1, my B is negative 5, and my C is negative 8. So I'll just plug it into this formula. So I've got negative B, B is negative 5, plus or minus square root. B squared, make sure right here you put parentheses around that negative 5 before you square it, or it's not going to work. Negative 5 squared minus 4 times A, which is 1, C, which is negative 8, all over 2A, so 2 times 1. Now, when you do these problems, you can type them into the calculator. It will give you the decimal answer. But on a lot of these, they don't want you to give the decimal answer. They want you to give the exact answer, so they want your answer to look like 5 plus or minus root 8 over 7 or something like that. So whenever you're evaluating this, if you need an exact answer, you want to take this stuff right here underneath the root, and you want to figure out what that is. You can do it in your head, or you can type it into Desmos. Don't put the square root there, though. So we want negative 5 squared, which will give us 25, minus 4 times 1 times negative 8 right there, and I'm getting 57. So all that stuff right there I have is 57. What happens when I've got a negative 5? That's really a positive right there, isn't it? So I've got x equals positive 5 plus or minus the square root of 57 all over 2. And these are our two answers, right? It doesn't look like two answers, but it is, because one has a plus and one has a minus there. So these are our two answers for that. Now, you can get a decimal if you need it for something, but a lot of times these are going to be given with your answers looking like this. So that's not really a question that we would be asked in this course, but let's look at where it comes in. Okay, so let's look at this function right here. I've got 2x minus 3, and then I've got x squared minus 4x minus 10. And I'm looking for the x-intercepts. X-intercepts is another word for my real zeros, right? The zeros I can find on the graph. Definitely you can graph this and find it on Desmos. What I see a lot of times, though, is the answer is that exact where they found it with quadratic formula. So you may need to have that instead of the decimals that Desmos will give you. So this will not factor, because to multiply to get negative 10, I'd have to use negative 2 and 5, or 2 and negative 5. And neither one of those give me negative 4. So it won't factor. So I'm going to set each one of these equal to 0. So I'm going to say 2x minus 3 equals 0, and I'm going to say x squared minus 4x minus 10 equals 0. This first one is just a simple equation to solve. So we are going to add our 3. We got 2x equals 3. We're going to divide by 2. So x is going to equal 3 halves. Right there is one of our zeros. For the second one, it doesn't factor. I've got to use quadratic formula on this. So I would say x equals negative b, so that's going to be negative 4 plus or minus the square root b squared, so negative 4 squared minus 4 times a, which is this 1 right here, times c, which is negative 10, all over 2 times a, which is 1. And so negative 4 is really just a positive 4, plus or minus. Right here, I've got negative 4 squared minus 4 times 1 times negative 10. It's going to be 56 if you can do it in your head, but if not, skip over here to Desmos, just type it in, negative 4 squared minus 4 times 1 times negative 10, we'll get 56. So we got plus or minus the square root of 56 all over 2. Now this one's a little extra tricky because I'm pretty sure 56 will break down a little bit further. We're going to do this in a second. If I've got 56, I think 4 goes into that. Let me 56 divided by 4 is 14. So that means 56 could be written like the square root of 4 times the square root of 14. All right, what is the square root of 4? It is 2. So that could be 2 right there. We'd have to leave the square root of 14 underneath because no number times itself gives you 14. So that means our answer could look like this, 4 plus or minus 2 square root of 14 all over 2. And when we get here, all of these numbers, 4, 2, and 2, are all divisible by 2. So if we divide everything by 2 right there, only the numbers on the outside of the root, not the one on the inside, we would just get 2 plus or minus. This is going to be 1 square root of 14, but we don't have to write the 1. And in the bottom there's a 1, but do we really have to write the 1 in the bottom? We do not. So we'd get 2 plus or minus the square root of 14. So those would be our other 2. That's actually 2 different zeros. Where to lose you, Trinity? And
why do I need this?
You can, but it's going to give you decimals. So, which is on a multiple choice question. On a multiple choice question is good enough most of the time because here, like if I graph this 3x, what was it? Minus 2 or plus 2? Or 2x minus 3. Sorry, 2x minus 3 times x squared minus 4x minus 10. So if I graph this, I get negative 1.741, I get 1.5, and I get 5.74166. But if I type in 2 plus square root of 14, that gives me the 5.741 right there. And if I type in 2 minus square root of 14, I get the other one that's over here. So as long as it's multiple choice, you can get around having to actually know how to do that just by graphing it and looking at the decimals and then matching it with your answer choices for that. These are, for what I'm going to give you, are going to be multiple choice if they have Like, I don't ever try to, like, give you one where you've got to type in something like 2 plus or minus the square root of 14. What they sometimes will do on the EOC is they might make it like a drag and drop sort of thing where you've got so many options, it's too hard to check everything in Desmos. But most of the time it's going to show up multiple choice for that. But I need you to know where it's coming from to understand that a little bit, but there are ways around it most of the time. These are still real zeros. Okay? They are not imaginary zeros. They are ugly real zeros, but they're still real zeros because we can graph them and we can see where they cross, right? So these are still real zeros. Sometimes we have imaginary zeros, and we're going to need to know what to do with that. And imaginary zeros, we cannot use Desmos for because imaginary zeros don't show up on the graph. So that's what we're headed to next. Before we can worry about that too much, we need a little bit of review on how to simplify radicals so we can remember what to do with these i's that maybe will show up. So the first two are not going to be imaginary. What is the square root of 25? That's just going to be 5. All right, 5 times 5 equals 5, so square root of 25 is 5. Is there a whole number for example 5? Can we do the square root of 32? Not a whole number, right? We could type it into the calculator and it will give us a big long decimal, but that's not what we would call an exact match because it's been rounded off. Even what the calculator gives you, there's more decimal places. Those numbers are what we call irrational, which means they go on forever and ever and ever and ever. So sometimes back in Math 1 and 2, you would have to simplify radicals. I know they do it in 2 because Hunter's just been doing it fairly recently. So perfect squares, numbers that do have square roots, are numbers like 4, right? The square root of 4 would be 2, right? 9, 3 times 3 is 9, so it's a perfect square. 16, 4 times 4 is 16. 25, 5 times 5 is 25. So those are what we call perfect squares. So what I want to do is take 32 and break it down so it's a perfect square times another number. So of these, what number would go into 32? How could I break it down? Like, for example, I could do 1 and 32. That would get me nowhere. 1's a perfect square, but it doesn't help. Right? What else could I do? Okay, 4 times, what? 8. 4 times 8 works, but there's a better one because there's a bigger perfect square that will go into it. And if you do 4 times 8, you have to break it down again. What do you got? 16 and 2. So if I break this into square root of 16 times the square root of 2, square root of 16 is 4. It comes on the outside of the square root because it is a perfect square. The 2 has to stay on the inside. So square root of 32 is the same as 4 times the square root of 2. That's what we had to do when we were like simplifying that quadratic formula question that we looked at just a second ago. Now, number 6, 16 is a perfect square, but is negative 16 a perfect square? It is not. No number times itself will give you a negative number. So when I have a negative under the square root, what I have to do is I have to treat that as like a times negative 1, right? So I'm thinking like I've got square root of 16, which is a perfect square. I can do that, multiplied by the square root of negative 1. What is the square root of 16? It is 4. What is the square root of negative 1? It has the name. What is it? It's the imaginary I. So we use that I right there. So we would call this 4I. Right? So if you have a negative that goes with the perfect square, it's just going to put an I next to it whenever you do that. The most complicated situation we might run into maybe is something like number 7. Because can we take the square root of 150 evenly? We cannot. It's not a perfect square, right? No number times itself equals 150. Whatever I do here is going to have an I because of that negative, but I also would have to break it down. What could I break 150 down into? What? 25 is going to go into 150 how many times? 6 times. So I'm going to have square root of 25, square root of 6, and then the square root of negative 1. And so square root of 25 is 5. Square root of 6, I can't do it, right? There's no number times itself that gives me square root of 6. So I'm going to leave it underneath the square root. And then what's square root of negative 1? That's I. Usually we'll put this right here with the 5 that's on the outside. It's not on the inside. I should never be on the inside of a square root. There. And they usually write like the number first, then the I, then the root. For that. So, this is some review. I'm not sure if you did that with I's or not in Math 2. You might have, but it's also perfectly feasible to think that you would have not done that at all. But you definitely should have done some of this, like breaking this down into 4 square root of 2. Now, we are going to have to do a little bit of this because we might get problems like number 8. Okay, and it asks us to find all the roots of the functions below. Okay, and this looks almost identical to the ones we were doing before, right? And I told you we could, on the ones we were doing before, we could graph them all. So if I graph this one here, I've got f of x equals 2x minus 1, x minus 5, x minus 5, and x squared plus 25. Here. Yep, and so I definitely have a 1/2 and a 5. But do I have any others? I zoom out. There's nothing there, right? It's just, those are my only 2 real x's, 1/2 and 5, which the x equals 5, you guys probably could have told me already. It comes from this one right here, right? Over here, I could have said 2x minus 1 equals 0. I could add 1. 2x would equal 1 divided by 2. X would equal 1/2 or 0.5, whichever way you want to write that. Those are my 2 real zeros. But this function could have imaginary zeros. And so, still not going to be a 0, though, because it's not where you're crossing the x-axis there. Yeah, there's only 2 places where we cross the x-axis. Imaginary zeros don't show up on the graph. That's one of the reasons we have to be able to do this by hand. And they might give you these problems. So you're going to have to be able to do at least part of this by hand. You could do the real zeros with the graph, but imaginary have to be done by hand. So the last part right here, I want to know where x squared plus 25 would equal 0. You can use quadratic formula on this if you want, but where you don't have that middle term, it's really a lot easier just to solve like you would a regular equation. So to solve this, I would have to subtract 25. And so I'd get x squared equals negative 25. And then what do I have to do to get rid of that square? Square root, right? Square root is the inverse of a square. So I would square root both sides. And so when I take the square root of 25, I get 5. But it's a negative, so what has to go with it? The I. And these will always come in pairs. So when you're square rooting both sides, really this is the case even if you don't have a negative under the square root. When you take the square root of both sides on the equation, you have to put a plus or a minus with it, right? So we actually would get two roots here. We'd get x equals positive 5i, and we would get x equals negative 5i. So it's similar to what we were doing on the other problems. We're just taking each factor and setting them equal to 0, right? It's just that whenever we do that, it happens to have an I in the answer. Okay, probably the most difficult question that you're going to get from this section is probably example 9. Okay? Because they ask you to find all of the zeros, which immediately, I immediately, when I'm thinking this, I was like, graph it in Desmos, right? Graph it and see where the zeros are. So that is what I would do. I would go to Desmos here, and I would just type it in. Y equals 2x to the third minus 4x squared plus 16x minus 32. And so here's my graph. If I zoom out, yeah, but y-intercept is not a 0. Okay, so the x-intercept is the only 0, 2. But how many zeros am I supposed to have for this one? This is a fundamental theorem of algebra. Not 5, 3. It's the highest exponent. I'm supposed to have 3. I only see 1. What does that tell me about the other ones? They're probably imaginary, right? So, since they are imaginary, this problem wants me to actually find what those are. But you can't do that from the graph. So, what I'm going to have to do, unfortunately, like I said, this is sort of like the hardest problem. This is one of those problems you need to know how to do it to make 100. There's not going to be a lot of problems like that on there. I know x equals 2 is going to be a 0. Right, it's one of my zeros. It's one of my answers. But the other ones I can't find. So what I've got to do is I got to factor this back out so that I can solve this. And the only way to factor when you have something like x to the third power, or at least the only way we really know, right here is to do some long division. Okay, so if x equals 2 is my 0, what's the factor that goes with x equals 2? Like if I were to factor it out, what's it going to have in parentheses? Like up here, x equals 5 was my 0, x minus 5 was my factor. So if x equals 2 is my 0, what's my factor going to be? X minus 2. So I've got to take this function and divide it by x minus 2. It'll give you the remainder, but the remainder should be 0 because it's going to be a factor, and that won't help us. What we need is that other stuff you get when you divide. So there's not a lot of things in this chapter that you actually have to do long division for, but this is one of them. You're actually going to have to do it. If you remember how to factor by grouping, I think this one does factor by grouping, but we're not going to go back over that technique and further confuse you and add that to it. We're going to stick to the things that we got right now. So, for this one, I need to ask myself, what times x gives me 2x to the third? What times x would give you 2x to the third? So there's no number with this x right here, so it's going to be 2x squared. Because if I do 2x squared times x minus 2, and I distribute here, 2x squared times x gives me 2x to the third. 2x squared times negative 2 gives me negative 4x squared. So this is what I'm going to write right here, 2x to the third minus 4x squared. What do I have to do after I write that down? Got to subtract it. So I'm going to subtract this and subtract this. This goes away, this goes away. And then whenever I do that, I got nothing here. I'm going to just need to bring down the next step, 16x minus 32. So then I have to ask myself, what times x would give me 16x? And what would my answer be there? What times x would give me 16x? 4 times x is 16x. This x right here doesn't have a number, right? It's just a 1. So it's just going to be plus 16. Right? Because if I take 16 and I multiply it times x minus 2, I will distribute right here 16x minus 32. So I'll write that right here. And same thing ends up happening right here when I subtract this. Both things cancel. So this is what I get. I got a remainder of 0. What this means is that this function can be written as x minus 2 times 2x squared plus 16. Right? It factors it back out. So, like we did up here for number 8, now that it's factored, I could just set each piece equal to 0. Well, this one would just give me 2. I've already got that, right? But here, I could do 2x squared plus 16 equals 0. And I would need to solve that for my x. So I would subtract the 16. So 2x squared would equal negative 16. I would need to divide that 2 off first before I take the square root. So I'll divide by 2, divide by 2. And so x squared equals negative 8. And then I will square root both sides. And so x will equal, I can't take the square root of 8. I can break the square, so when I'm trying to do square root of negative 8, I can break it down because it could be the square root of 4 times the square root of 2 times the square root of negative 1. And so what's the square root of 4? It would be 2, square root of 2, and then that negative just becomes the I. So I get plus or minus 2I root 2. So if I want to list them all separately, it's x equals 2, x equals 2I root 2, and x equals negative 2I root 2. Let's see here. I don't know if Desmos will do this or not. Let's see if it will. So let's say, I'm going to change this to f of x instead of y. So like, if you're wanting to check your work beyond the graph, you definitely could just do like f of 2 and make sure you do get 0. Let's see if it does it with i's. F of 2i square root 2. No, it does not recognize I as that. What if I did square root of negative 8? Desmos can't handle that. So if you have imaginary roots, you're on your own on that. Desmos will help you find the real ones, but not the imaginary for those. Okay, questions there? Okay, we're going to keep going with some of these other things in a second, but I would like for us to pause so you can practice this a little bit before we go on to the end of these notes. So if you will go to your Amplify, I want to know which graph matches. I could type it into Desmos, but it is going to be faster just to look at zeros. You've got x equals 3 should be a 0. So all of these have zeros at 3. But what happens on A and B at 3? What type of 0 do you have? You got a bounce. Are you supposed to have a bounce at x equals 3? You are not supposed to have a bounce at x equals 3 because you don't have a square that goes with this. So C has got to be the answer for this. You also, right here, you got x equals -1, but it's a double root, which means you should have a bounce at -1. And if you look at this graph, it has a bounce at -1. And this looks like it would be something else, but if you've got x squared plus 4 equals 0, you're going to subtract that 4. X squared is going to equal -4. You're going to square root both sides. So x is going to equal plus or minus. This is going to be 2i. That's going to be imaginary right there. So that's not extra zeros. You can't really see that on the graph. So it's got to be C. Okay, so sometimes they will give us the zeros and ask us to write the equation. So if blank is a 0 of f of x, then blank is a factor of f of x. So if, I'm going to call it a again, it could be any number, right? If a is a 0 of f of x, then x minus a is a factor of f of x. So for example, if I had a third degree function that has zeros at -1, 2, and 0, then one possible equation would be x times x plus 1 times x minus 2. This x equals 0 right here goes with just having an x out front, right? That would be 0. And then instead, if I have a -1, that means I'll have x plus 1 as a factor. If I have a positive 2, that means I have x minus 2 as a factor. It is also possible to have, like, it doesn't really matter what number I were to put in front of that. I could put a 3 right there. I'd have the same zeros. I could put any number right there, a, whatever. I would have the same number of zeros. So occasionally you might see this where there's like an A out front, but that is not going to be something we've got to do much for that. So let's look at writing equations. Write a possible equation for a function that has exactly 3 real zeros at x equals 3, x equals 5, and x equals -2. So this should be pretty simple if we're writing this function. We're going to have f of x equals 3. What will I write for it? X minus 3, right? Just use the opposite sign. At x equals 5, I'll use x minus 5. And at x equals -2, I will do x plus 2. And that'll be it. You could put any number you want to right here, and it would still be true. But I'm not going to throw in extra numbers if I don't have to. Now, 12 is a little different. 12 you're going to have to throw in extra numbers for, because it says we're supposed to write this equation and we have a leading coefficient of 2. That means the number out front is 2. So when I'm writing this equation, I'll have like f of x equals 2, and then I'll start my equation. All right, so if you see leading coefficient of 2, that's what that's talking about. I have a 4th degree polynomial, which means I've got 4 zeros, although they might not be distinct zeros. I've got zeros at x equals 2, so that means I would write x minus 2, right? And x equals 0. If you wanted to, you can write it like this, x minus 0, or plus 0, doesn't matter. 0 doesn't have a sign, so it doesn't matter. Those both have a multiplicity of 1, so they're only there twice. And then I've got negative 3, so I'll have x plus 3. Now, technically, this is correct right here. This works. They're probably not going to write the final answer like this because of this x minus 0. What is x minus 0? Not 0, but just x, right? Because that 0 kind of like goes away. So they probably, if it's multiple choice, are going to write the answer like this. They'll put 2x times x minus 2, x plus 3. A lot of times if you have an x minus 0, they'll put that first, right here behind the whatever coefficient you have. And you can always graph these to make sure they look like, oh, I've messed up though. I'm not done. I've overlooked something. What did I ignore? It's got 4th degree, which means it's supposed to have 4 zeros, but this would only have 3 zeros. This would have negative 2, 0, and 3. Or, I mean, 2, 0. Multiplicity of 2. What should I do when I have the multiplicity of 2? We're just going to put a square right here, and then that will fix it. So that negative 3, 0 counts twice for that. But I left it off. Silly me. All right, so we got a couple more. So this tells us to write a possible equation for the graph shown below. So when I'm looking at this, I'm looking for my zeros. I got a 0 at negative 2, I got a 0 at 0, and I got a 0 at 3. That means I will have x plus 2, I will have x minus 0, and I will have x minus 3. I also need to consider multiplicity. Do any of those zeros have a multiplicity of 2? Which one? That double 0 one right there. That's a bounce, right? It doesn't cross the graph. It just touches it and goes right back down. So this one should have a square with it. Once again, they are probably not going to write it like this. It would just be x squared times x plus 2 times x minus 3. The first line's correct. It's just probably not what the answer choice is going to look like if it's multiple choice. Okay, and so our last one, it gives us all of this and asks us which one is equivalent. Now, this one is really just going to be best for you to graph it. I can think about zeros here if I want, but you're going to have to graph your answer choices unless you're going to do some extensive long division anyway. So I would do h of, I'm going to use an x instead of t, 2x, x minus 3, x plus 2 squared. Is that all? Yeah. And then, goodness gracious. I know it's not d because that's to the 5th power. So I'm going to try. I also know it should start with a 2t squared, but let's just try. It's not this one because I'm getting different graphs. I would try the next one. Plus 2 minus 16 minus 24 x. That one's it, isn't it? Yep, that's it. So B would be our correct answer. So anytime it really, even if it's like logs, exponentials, anytime they're asking which one's equivalent, you can just graph your answer choices. So, finishing the Amplify assignment is all you have to do. You guys are already halfway done with that, so hopefully it won't take you much longer to get that done. There is also the practice quiz on there.
Do we have to do the practice quiz?
You do not have to do the practice quiz. It is extra credit. The Amplify assignment is required. Yeah.